Our planet is a living, dynamic world, constantly in motion and full of surprises. From the vast blue oceans to the highest mountain peaks, Earth is always changing, shaped by powerful forces both seen and unseen. Deep within, it is constantly reshaping itself from within, as continents drift and landscapes transform over time. Far beneath us, immense heat and pressure drive the slow but relentless movement of continental plates, setting the stage for dramatic changes on the surface. These massive plates drift, collide, and pull apart, creating towering mountains, plunging ocean trenches, and vast rift valleys that shape the face of our world. Even the ground beneath our feet, which seems so solid and permanent, is part of this ongoing transformation. We live on a thin, fragile crust, always in motion, sometimes shifting so slowly we barely notice, and other times with sudden, dramatic force. This movement is both creative and destructive, building new landscapes and erasing old ones, shaping Earth over billions of years into the planet we know today. Volcanoes are dramatic reminders of this power, direct windows into the planet's fiery heart, where molten rock and gas escape to the surface in spectacular displays. Eruptions release heat and pressure, create new land and enrich soils, making them some of the most fertile places on Earth for life to thrive. Over millions of years, volcanoes have even helped shape our atmosphere, releasing gases that have made life possible. To understand volcanoes is to understand a key part of our own existence, as they connect the deep interior of our planet to the surface where we live. The ground beneath us is not as solid as it seems. It is alive with energy, always shifting, always changing. Occasionally, Earth's inner fire breaks through, reminding us of its true, untamable nature and the incredible forces at work beneath our feet. These places demand our respect, curiosity, and vigilance as we continue to explore and learn from the ever-changing story of our remarkable planet. In the Cascade Range of the Pacific Northwest, a chain of volcanoes rises dramatically from the landscape, born from the slow, relentless collision of tectonic plates deep beneath the Earth's surface. These mountains are not just scenic wonders, they are powerful reminders of the dynamic forces shaping our planet. Mount St. Helens, once a tranquil snow-capped cone, erupted with astonishing violence in 1980. The event shattered the mountain's peaceful image and forever changed our understanding of volcanic power and unpredictability. The eruption was a wake-up call, not just for scientists, but for everyone living in the shadow of these giants. Today, scientists keep a vigilant watch on Mount St. Helens, using advanced technology and constant observation to track every subtle change. In early 2025, a swarm of small earthquakes was detected beneath the mountain, sending a ripple of concern through the scientific community and local residents alike. For volcanologists, these tremors are a familiar sign, evidence that magma is shifting and moving deep below the surface, a reminder that the volcano is never truly at rest. These signals show that the volcano is alive and active, not necessarily on the verge of eruption, but slowly recharging its immense energy, preparing for whatever comes next. The 1980 eruption, triggered by a massive landslide, unleashed a lateral blast of ash, rock, and gas that devastated hundreds of square miles, reshaping the landscape in an instant and leaving a lasting scar on the region. It was a humbling display of nature's force, a reminder of how quickly the familiar can become unrecognizable. Now, Mount St. Helens is one of the world's most closely monitored volcanoes, bristling with sensors and instruments that provide real-time data to scientists around the globe. The lessons learned here have revolutionized how we predict eruptions, improving our ability to warn communities and save lives. Recent tremors confirm that our models and monitoring systems are working, giving us valuable insights into the volcano's inner workings. The mountain is slowly rebuilding itself, with new lava domes rising from the crater and life gradually returning to the once devastated slopes. With every rumble, our understanding of these powerful forces grows deeper. Mount St. Helens has become a living laboratory, where fear is transformed into knowledge, and every discovery brings us closer to coexisting with these volatile wonders. Here at the edge of the crater, we learn to respect and adapt to Earth's fiery temperament, forging a deeper connection with the restless planet we call home. Deep in the heart of Wyoming, where the wild stretches on for miles and the land feels untouched by time, lies Yellowstone National Park, a place renowned not only for its breathtaking geysers and abundant wildlife, but also for its raw, untamed beauty that draws millions of visitors each year. Yet beneath this stunning landscape, hidden from view, lurks one of nature's most formidable forces, a supervolcano, far larger and more powerful than any typical volcano found elsewhere on Earth. Unlike the classic cone-shaped volcanoes we often imagine, Yellowstone is actually a vast, underground reservoir of molten rock, stretching for miles beneath the surface. Over thousands of years, immense pressure builds up within this chamber, until eventually, it can erupt with a force powerful enough to reshape entire continents and alter the course of history. The entire park sits atop a giant, collapsed caldera, a vast depression left behind from its last cataclysmic super-eruption, which occurred over 600,000 years ago. If Yellowstone were to erupt again, the resulting ash and gas could blanket entire continents, disrupting ecosystems and human life on a global scale. Such an eruption could trigger what scientists call a volcanic winter, plunging temperatures and causing widespread crop failures and food shortages. While the odds of this happening in our lifetime are low, the consequences would be so severe that scientists closely monitor every tremor and change in the park. Understanding Yellowstone's supervolcano is critical, not to predict the exact date of the next eruption, but to grasp the immense scale and potential impact it could have on our planet and civilization. The park's famous geysers and hot springs are gentle, mesmerizing reminders of the immense power simmering just below our feet, hinting at the forces that shape our world. Yellowstone is truly a sleeping giant, one that continues to shape our world in ways we're only beginning to understand, reminding us of the delicate balance between beauty and power in nature. To understand Yellowstone, we must look deep underground. The magma system is a vast, multi-layered labyrinth, not a single cavern. Imagine a sponge-like network of molten and semi-molten rock stretching for miles. There are two main magma chambers, a shallow, sticky rhyolitic chamber and a deeper, hotter basaltic reservoir. The lower chamber recharges the upper, keeping the system active. Only a small fraction is actually liquid at any time. The rest is hot, crystalline mush. This complexity makes predicting Yellowstone's behavior challenging. The upper chamber alone could fill the Grand Canyon many times over. Movements within this network cause the ground to rise, power geysers, and trigger earthquakes. Scientists explore this hidden world using physics, mapping its fiery heart from afar. How do we study a world miles beneath our feet? Scientists use seismic tomography, like a CT scan, to map magma with earthquake waves. Seismometers around Yellowstone reveal the size and shape of magma chambers. Magnetotellurics measures electrical currents to detect molten rock, like a planetary metal detector. GPS and satellite radar track ground movement, showing if the system is inflating or deflating. These tools provide a real-time pulse of the volcano. Together, they give us a clearer picture of Yellowstone's hidden structure. Monitoring these vital signs helps us listen for any hint of change. Yellowstone's past eruptions reveal its true power. 3 colossal eruptions shaped the landscape: Huckleberry Ridge, Mesa Falls, and Lava Creek. The largest, over 2 million years ago, spread ash across North America. The most recent, 631,000 years ago, formed today's caldera and blanketed distant states in ash. These ancient ash layers are geological fingerprints, helping scientists reconstruct past events. By studying them, we learn about eruption size, style, and environmental impact. This detective work informs our models and hazard plans. Compared to Yellowstone, eruptions like Mount St. Helens are minor. Even recent global eruptions are dwarfed by Yellowstone's past. Smaller eruptions teach us in real time, helping us refine our monitoring techniques. Monitoring Yellowstone is a continuous collaborative effort. The Yellowstone Volcano Observatory synthesizes data from a vast network of sensors. Their mission: detect any sign of change in the volcano's behavior. A super eruption would give decades of warning: intense earthquakes, rapid ground uplift, and dramatic changes in gas emissions. The knowledge we gain is vital for safety and resilience. Understanding volcanoes moves us from fear to informed respect. International collaboration is essential, as eruptions have global consequences. Science allows us to coexist with Earth's awesome forces. Our quest for knowledge is the key to a safer future.